Simplify radical expressions. So radical expressions involve square root symbols or our radical sign. When you solve these, they need to be in simplest form, so three things need to be true in order for it to be in simplest form. The first is that you cannot have any other perfect square factors underneath your radical sign. The second thing is you can't have any fractions underneath your radical sign. And the third one is that your radical cannot be in the denominator. So we'll work through these examples as we go. In order to solve these, you're going to do that prime factorization. So if I had 6, the prime factorization is going to be 2 times 3, because 2 and 3 are both prime numbers. They can't be divided out any further or factored out any further. And when you multiply them together, you get 16. So once you do this prime factorization, you're going to factor out all of the perfect square results, and whatever is left remains underneath the radical. So if we look at example 1, I've already have it all the way worked out for you. So if I have the square root of 54, that divides into 9 and 6. 9 is a perfect square. However, if you wish to solve it out further, you may. So it'll break down into 3 and 3. 9 times 6 is going to give you 54, and 6 is not a prime number or a perfect square, so it can divide further into 3 and 2. So when I rewrite this, I have 1, 2, and 3 3's that I'm multiplying all together to equal that 54. When I look at them, I have 2 3's here, which means that would be the square root of 9. And when I solve the square root of 9, it's a perfect square, so I'm going to get the whole number 3. And what I have left underneath my radical is the 2 times 3, which is going to give you that 6. So instead of solving all the prime factors all the way out, you can look for perfect squares until you can't do perfect squares anymore. So again, 9 was a perfect square. I have 6 left, so the square root of 9 was 3, and I had 6 left underneath. So you don't have to go all the way out to here. Just make sure that you don't have any other prime factors in your radical. So if we look at example 2, I have 180. 180 breaks down into 9 and 20. 9 is a perfect square, so I know that I'm going to have a 3 on the outside of my radical. 20 breaks down further into 4 and 5. 4, I also know, is a perfect square, so that's going to multiply by 2 because the square root of 4 is 2. And I have 5, which is a prime number, left inside my radical. So whatever you're factoring out or square rooting out, you're going to multiply those pieces together. So 3 times 2 is going to give me 6, and I still have my radical 5 left over. If I look down here at example 3, I have the square root of 6 times the square root of 8. You can do this one of two ways. You can factor these two together or separately. So I can factor 6 as 2 and 3, and I can factor 8 as 4 and 2. So I have this 4, which I know, and I also have these two 2's, and when you multiply those together, you get another 4. So it would be 2 times 2, and I would have this 3 left, so it would be 4 radical 3. The other way that you can do this is multiply your pieces together. So now I would have radical 48, and then I can go about solving it with 6 and 8. If I look for a perfect squares here, I know that I would have 4 and 12, and I know that 12 breaks down into 4 and 3. So I again have 2 4's here, which means I would have a 2 times a 2, and then what I have left. So again, I would get 4 radical 3. So it doesn't matter which method you use. If you do them separately first and then figure out what they have in common. So if I looked at all of these, I would have 2 times 2 times 3 times 4. These two and this one would make those perfect squares. Or you can multiply, do the actual operation, and then factor it out that way. Either one is acceptable. If I continue with example 4, I have 4 radical 2 times 5 radical 8. Since we're multiplying, you're still going to multiply these coefficients together. So I'm going to do that first and get 20. Keep that off to the side. So now you're working with radical 2 times radical 8. 8 and 2 is going to give you 16. And we know that 16 breaks down into 4 and 4, so it's a perfect square. So I'm going to factor out 1 4 because the square root of 16 is 4, and I'm going to multiply it to this 20, so my answer is going to be 80. We have more. If we look at example 5 here, now we have some variables. Remember before, if we had 2 of the exact same, then one of those factored out. So I'm going to first break down my 28. I have 4, which is a perfect square, and 7. So now if I rewrite this, this is telling me I have 4 times 7 times 2 a's, 1, 2, times 3 b's, 1, 2, 3. So now it's looking for what you have 2 of, or perfect squares. So I have a perfect square of 4. The square root of 4 is going to be 2. I have 2 a's, which means one of them gets factored out. I have 2 b's, which means that one of them also gets factored out. And what I have left, the single 7 and a single b, stay underneath your radical. So I have no perfect squares under here, and I don't have more than one exponent on my variable, so this would be your simplest form for that problem. If we look at example 6, we have a 7 out in front already, so that's going to stay there for now. When we factor out our 63, it is going to break down into 3 and 21. 21 can break further into 3 and 7. You also could have started with 9 and just done 9 and 27 and recognized that 9 and 7, and recognized that 9 was a perfect square. So when I break this down, I have 3 times 3 times 7 times m times p. So again, you're looking for 2 things that you have in common. So I have 2 3's. So other than the 7 that I already have out in front, I'm now going to have 1 3. I have 2 m's, so that'll be an m. And I don't have doubles of anything else. So what I have left, the 7, the m, and the p, stay underneath the radical. So the only thing I need to simplify now is by multiplying my 7 and my 3 together. So I'm going to get 21m radical 7m p. So this would be your final answer. If I look at example 7, you can see that you have 2 separate radicals, so you can solve them separately and then combine them at the end. Or you can combine them at the beginning and do it separate, and factor out as a combined unit. So if I multiply them together, I'm going to end up underneath my radical with 20a to the 6th, because remember you add your exponents. So I'm going to end up with 20 a to the 6th b to the 3rd. So when I factor out 20, I have and 5, I know that 4 is a perfect square, so I'm going to have 2 on the outside. If I have 6 A's, that means I have 3 groupings of 2. So if I have 1, 2, 3, 4, 5, 6, I have 1 group, 2 group, 3 groups. So I have 3 groups of A, which means I have no more 6's. And if I have 3 B's, I only have 1 group of 2, and I have 1 B left. So I have a 5 and a B left underneath my radical. So the answer is going to be 2A cubed B radical 5B. If I look at example 8, as you can see, I have radicals in both parts, or it's doing a radical for the whole fraction. So the first thing you need to do is simplify your radical. So now underneath my radical, I know that they're both divisible by 5, so I'm going to end up with 9 over 2. So this is kind of like the squaring piece. If you had a fraction and you were squaring it, it applied to both pieces. So similarly, if you're doing the square root, you have to square root both pieces. So I'm doing the square root of 9 over the square root of 2. If you recall back in our simplifying, we can't have a radical in the denominator. So in order to get rid of it, we're going to multiply both pieces by that radical. Because now when I multiply my 2 radicals together, if I have 2 times 2, that's going to give me the square root of 4. And if I have 9 times 2, that's going to give me the square root of 18. The square root of 4 is a perfect square, so it's going to spit out a 2, square root of 18. And now I just need to factor this like I've done above. So 18 breaks down into 9 and 2. We know that. 9 is a perfect square, so I would have a 3 on the outside. I have a 2 left over, and then my denominator is still going to be that whole number 2. You don't need to do this part if you recognize that the square root of 9 is a perfect square. So if I start here, I'm going to show you a second way. If I know that square root of 9 over the square root of 2, I know that 9 is a perfect square, so I can factor that out, or solve it. So I have a 3 square root of 2. Now I would have to multiply both sides by that square root of 2. So it's going to give me 3 root 2 over the square root of 4, which would also give me 3 root 2 all over 2. So you don't need to combine these two. You can start by solving the square root of 9 and then going about the denominator. 2 more examples. Example 9 is if you have an operation with a radical in the denominator. The way you do this is by multiplying both pieces by the opposite sign of this. So the whole thing, 2, only now I'm changing my sign, radical 2 on both pieces. What you do to one, you have to do to the other. So when I solve this, it's going to kind of be like the distributive property. So I would have 3 times 2 minus root 2 over 2 plus root 2 times 2 minus root 2. So again, when I go about solving this, do my distributive property, so I'm going to get 6 minus 3 root 2. If there's not a number in front of it, it's understood to be a 1, over, you would have to do your FOIL method. First, outer, inner, and last. And then simplify what you can. If I have minus root 2 plus root 2, that middle term drops out. So what I'm left with is 6 minus 3 root 2 all over 4 plus the square root of 4 is equal to 2. So I'd have 4 plus 2. So I'm going to end up, oh, I apologize, it should be a minus, because positive times negative gives me a negative. So when I subtract them, I get 6 minus 3 root 2 all over 4 minus 2 is going to give me 2. So this would be your final answer for example 9. And the last one, for example 10, you're going to do the same concept like you did up in example 9. I'm going to switch colors. So you're going to multiply both pieces by this expression, but the opposite sign. So 2 plus root 6, 2 plus root 6. So when I multiply them, we'll rewrite it. So I have 5 times 2 plus root 6 all over 2 minus root 6 times 2 plus root 6. So distributive property, 5 times 2 is 10, plus 5 times root 6 is 5 root 6. Down here, my firsts are going to be 4. My outers are going to be plus 2 root 6. My inners are going to be minus 2 root 6. And my lasts are going to be minus root 36. So when I go to simplify, nothing can change in the top. So I still have 10 plus 5 root 6 in my denominator. Plus 2 root 6 and minus 2 root 6, those are going to cancel. So I'm going to be left with 4 minus 36 is a perfect square, which is why we're doing this. And it's going to give you a minus 6. So when I solve this, I get 10 plus 5 root 6 all over a negative 2. So this would be your final answer for that problem.